Hello students, this is Jisha Mary Jose, Assistant Professor, Department of Computer Science, Rajagiri School of Engineering and Technology. In this presentation, we are going to deal with the course CS307 Data Communication, which is a part of the 5th semester BTech of Kerala Technological University. In this presentation, we will be discussing the various topics of the second module of data communication, and the textbook that has been referred is Data Communication and Networking by B.A. Furzan, 5th edition. Anything that can carry information from a source to a destination is known as a transmission medium. In this module, we will be studying in detail about the different transmission media that are used in computer networks. If you consider some examples, day-to-day examples, suppose a person is talking to another person, then the transmission medium is air. Another example is suppose a person is writing a letter for another person. Then what is the transmission medium? It will be the mail truck or the postman who is going to carry that letter from the source to the destination. So transmission media is of different types. It can be free space, it can be air, or it can be metallic cables, fiber optic cables, or it can be anything. Okay, now if you consider the evolution of communication, it has come a long way. It started off with the concept of telegraph that was introduced by Morse in 1837. In this particular method, the transmission media that was used was metallic cables, but the disadvantage of this method was that the distance of communication was very less. After that, telephones were introduced by Graham Bell in 1869. This increased the distance of communication, but here also the transmission media that was used was again metallic cables. After that, there was a huge advancement in communication where wireless communication was introduced by Hertz in 1895, which included different technologies like radio as well. Here again, the distance of communication increased and the transmission media that was used were electric signals and waves which travel through air. After that, wireless telegraphy was introduced by Marconi and various other technologies came into being. And after that, as the years came down the line, sophisticated transmission media like optical fibers were introduced in 1960s, which could increase the distance of communication across continents. And like that, the evolution of communication and transmission media have been going on. This figure shows the location of the transmission media in the OSI architecture. We have the sender and receiver, and at the physical layer of the sender and receiver we have the transmission medium, which can be used for transferring information from the sender to the receiver. And the transmission media can either be cables or it can be air. The different components of the electromagnetic spectrum can be used for telecommunication nowadays, and these components include power waves, radio waves, infrared waves, visible light, UV light, X-rays, gamma rays, cosmic rays, etc. Any of these components can be used through different transmission media for transferring data or information from a source to a destination. Now, based on the type of components that are used, the transmission media can be classified into different types. As you can see in this diagram, transmission media is broadly classified into two types, guided media and unguided media. Guided means it will be a wired transmission medium, that is, there is a physical wire present, whereas unguided media means it is a wireless transmission medium, that is, no physical wires are present. And the guided media can be again classified into three types: twisted pair cables, coaxial cables, and fiber optic cables. And the unguided media usually includes free space, which can be used for transmitting of information. First, we will talk about guided media. They are media that can provide a conduit from one device to another, and a signal that is traveling along any of the guided media will always be in a directed form and is contained by the physical limits of the medium that is used. This wired or guided media is of different types. Here we are discussing three of them. First one is twisted pair cable, Next is coaxial cable, and the last one is fiber optic cable, out of which twisted pair and coaxial cables are made of metallic copper conductors and they transport signals in the form of electric current, whereas optical fiber cables are made up of glass or plastic and they transport signals in the form of light. Twisted pair cables consist of two copper conductors which are separately plastic insulated and are twisted together. One of the wires will be used to carry the signal and the other wire will be used as a ground reference, and the receiver will use the difference between the two to obtain the corresponding signal. Now, a problem that can happen in the case of twisted pair cables is that there can be effect of interference and crosstalk which can travel along with the signals. And here is the mechanism of twisting that will help. Why are the pair of cables twisted together? The twisting of the cables will help to cancel the exterior electromagnetic interferences effect, and more twists per unit length will result in better results. This figure is an example of a twisted pair cable. Here you can see two copper wires which are separately plastic insulated and they are twisted together. So this is a diagrammatic representation of a twisted pair cable. The most commonly used twisted pair cable in communication systems are UTP or unshielded twisted pair. The company IBM produced a version of the twisted pair cable known as STP or shielded twisted pair. So there are two types, UTP and STP. Now what is the difference? The shielded twisted pair has got an extra metal foil or braided mesh covering for each pair of the insulated conductors. And what is the advantage of this? It provides better noise resistance compared to UTP, but the disadvantage is that it is more bulkier and expensive, and that is why this STP or shielded twisted pair is only used in IBM applications, whereas in almost all other communication applications we use UTP. The Electronic Industries Association EIA has developed different standards to classify the unshielded twisted pair cable into 7 categories, and these categories are determined by the quality of the cable, with category 1 having the lowest quality and category 7 having the highest quality, and each of these categories are suitable for specific uses as shown in this table. For example, category 1 unshielded twisted pair can be used in telephones, whereas category 2 unshielded twisted pair is used in T-lines and so on as shown in this table. The most common connectors used for twisted pair cable are RJ45 or registered jack 45 connectors. It is actually a keyed connector, that is only one way insertion is possible. In this diagram you can see the RJ45 male part and the female part, and you must have seen it in the Ethernet LAN connection cables. So this is the popular RJ45 connector. To measure the performance of a twisted pair cable, we can compare the attenuation and frequency. A twisted pair cable can pass through a wide range of frequencies as shown in this diagram, and we can also see that as the frequency increases, the attenuation that is measured in decibels per kilometer is also sharply increasing with after frequencies above 100 kilohertz. And here we have actually measured the attenuation of twisted pair cables whose gauge value is 18, 22, 24 and 26, and gauge means it is a measure of the thickness of the wire. Applications of twisted pair cable include: they are most popularly used in telephone networks for voice and data channels. They are also used in the DSL lines of telephone companies, and also local area networks like 10 base T and 100 base T also use twisted pair cables. So in this diagram you can see the representation of twisted pair cables used in real life. So the next transmission media that we are going to discuss is coaxial cable, also popularly known as coax. It actually carries signals of higher frequencies compared to twisted pair cable, and the main composition of coaxial cable is it has got a central core conductor of solid or stranded copper wire which is enclosed inside an insulating sheath. Now this is again enclosed by an outer conductor of metal foil, a braid, or a combination of both, then that is again enclosed inside an insulating sheath, and the whole cable is protected by a plastic cover. So you can understand how many levels or how many layers of protection is given to this particular cable so that we can reduce the effect of interferences and noise. As you can see in this diagram, the coaxial cable consists of only a single copper wire, and this single copper wire is covered or enclosed by an insulator. Then that insulator is again enclosed by an outer conductor, which can either be a metal foil or a braided mesh. Then after that again an insulator covering is provided, and finally the full wire is put inside a plastic cover. So this is the diagrammatic representation of a coaxial cable. Compared to twisted pair cable, here there is only a single copper wire, whereas in twisted pair cable there were two copper wires which were twisted together. Coaxial cables are categorized by the radio government ratings or RG ratings, and these RG ratings are based on various physical specifications like the wire gauge of the conductor or the thickness and type of the insulator used, the construction method of the shield that is used, and the size of the outer casing, etc. So based on these kind of specifications, the RG ratings are provided, and as you can see in this table, there are three categories: RG59, RG58 and RG11, and these cables will be used for various purposes like cable TV, thin Ethernet, thick Ethernet, etc. Coaxial connectors are used for connecting coaxial cables to devices. The most common type of connector that is used is the BNC connector or Bayonet Needle Concealment connector. And there are three popular types of BNC connectors: the normal BNC, BNC-T and BNC terminator. The BNC connector is used for connecting the end of a cable to a device, like for example a TV. The BNC-T connector is used for connecting Ethernet networks to branch out to a connection to a computer or other device. And the last one, that is the BNC terminator, is used at the end of the cable to prevent the reflection of signals. So these are the three types of BNC connectors used for coaxial cables. The performance of coaxial cables can also be compared by considering the attenuation in decibel per kilometers and the frequency in kilohertz. If you see the graph, you can see that the attenuation is much higher in coaxial cables than in twisted pair cables. That is, even though the coaxial cables have a higher bandwidth, the signals weaken rapidly and they often require the use of repeaters. So this is a graph representing the comparison between attenuation and frequency of coaxial cables. Coaxial cables are popularly used in analog and digital telephone networks, cable TV networks, and traditional Ethernet LANs. A fiber optic cable is made up of glass or plastic and it transmits signals in the form of light. To understand the working of fiber optic cables, first we need to explore some of the properties of light. We know that light always travels in a straight line as long as it is moving through a single uniform substance. If a ray of light is traveling through one substance and it suddenly enters another substance, then there is a possibility of the change in direction of the ray. Now in this diagram you can see three possible scenarios. If the angle of incidence I is less than the critical angle for a particular ray, then the ray will refract and move closer to the surface. If the angle of incidence is equal to the critical angle, then the light will bend along the interface. And if the angle of incidence is greater than the critical angle, the ray will reflect and travel again in the denser substance itself. And we should always remember that the critical angle is a property of a substance and its value can differ from one substance to another. So this is the concept that is used for the building of fiber optic cables. In this diagram, you can see the construction of a fiber optic cable. It consists of two parts, a dense glass or plastic core and a lesser dense glass glass or plastic cladding, and this core is surrounded by the cladding. And as mentioned in the previous slide, fiber optic cables make use of the property of reflection to guide light through a channel. So in this diagram you can see the sender will send out a signal in the form of light, and it uses the property of total internal reflection. That is the third case. That is, the angle of incidence will always be greater than the critical angle of the surface, so that the light will get reflected inside the core itself, and like that the light will travel towards the receiver. This is how the light is passed through fiber optic cables. In the current technology, there are two modes which are used for propagating light along optical channels, which include single mode and multi-mode. And this will depend upon the different physical characteristics of the fiber. And the multi-mode itself can again be implemented in two ways, that is step index and graded index. So first we will see what is meant by multi-mode. Multi-mode is named so because multiple beams from a light source can move through the core in different paths, and how these beams are going to move within the cable will depend on the structure of the core. Based on that, there are two kinds of multi-mode operation: multi-mode step index and multi-mode graded index. In multi-mode step index, the density of the core remains constant from the center to the edges of the fiber, and a beam of light that is moving through this constant density in a straight line will reach its destination properly. But at the interfaces, there is an abrupt change due to a lower density, which will alter the angle of the beam's motion. And that is why this term step index is used, so as to refer to the suddenness of this change, which contributes to distortions of the signal as it passes through the fiber. Second one is the graded index or multi-mode graded index fiber, where the distortion of the signal is decreased throughout the cable. Okay, because the density is highest at the center of the core and decreases gradually to its lowest at the edges, and that is why lesser amount of distortion is present. And the last one is single mode. In single mode also, step index fiber and a highly focused source of light that limits the beams to a small range of angles, all close to the horizontal, is used. And that is why it is called single mode fiber, and it is manufactured with a very small diameter fiber than that of the multi-mode fiber, and with a substantially lower density. And the decrease in density results in a critical angle which is very close to 90 degree, so that the propagation of the beams is almost horizontal. In this diagram, you can see the three kinds of propagation modes. First one is multi-mode step index, second one is multi-mode graded index, and the last one is single mode. In the first one, as you can see, as the beam of light is traveling through the center of the core, it is traveling in a straight line, but as it moves towards the interface of the core and cladding, since there is a sudden variation in the density of the materials, there is an abrupt distortion of the signals. Whereas in multi-mode graded index, the variation in densities of the core and cladding is not very abrupt. That is, there is a gradual decrease of density from the center towards the edges. That is why sudden changes don't occur to the signal, and they can travel in a more better way. That is why compared to multi-mode step index, the signals that are received at the destination of multi-mode graded index are better in structure. And the last one is a single mode fiber, where the diameter of the core is very small compared to the diameters of cores in the multi-mode method, so that the light can travel in a single straight line which is very close to the horizontal and can reach the destination. So you can see the amount of distortion in single mode is very less compared to the first two methods. So these are the three kinds of propagation modes that are used for fiber optic cables. Optical fibers are defined by the ratio of the diameter of the core to diameter of the cladding. The following table shows some of the core cladding diameter values and the corresponding modes that are defined. Here we can see 50 by 125 type, where the core size is 50.0 micrometer and cladding size is 125 micrometer, and it is a multi-mode graded index fiber. Whereas the last one, that is 7 bar 125 type, here the core size is 7 micrometer and cladding is 125 micrometer, and it is a single mode fiber. So the different types of optical fibers are defined by the ratio of the diameters of the core and the cladding. If you consider the composition of fiber cable, it basically consists of an outer jacket which is made up of the material PVC or Teflon, and inside the jacket there are some strong Kevlar strands provided for strengthening the fiber, and inside the Kevlar strands there is a plastic coating to cushion the fiber, and inside that plastic coating the fiber material exists, which consists of the cladding and the core. There are three types of connectors used for fiber optic cables. As you can see in this diagram, they are the SC connector or subscriber channel connector, which is used for cable TVs, and it uses a push or pull locking system. The next one is the ST connector or the straight tip connector, which is used for connecting cable to networking devices. Then it uses a bayonet locking system or BNC locking system and is more reliable than SC. And the last one is the empty RJ connector, which is the similar or has the same size as that of RJ45. So the three kinds of connectors used in fiber optic cables are SC connector, ST connector, and empty RJ connector. If we consider the performance graph of fiber optic cables by plotting attenuation versus wavelength, we can see a very interesting factor over here. We can see that the attenuation is flatter than in the case of twisted pair cables and coaxial cables. And because of this reason, fewer number of repeaters are used in the case of fiber optic cables, because there is no much attenuation effect on the signals that are transmitted. If we consider the applications of fiber optic cables, they are popularly used in backbone networks like SONET because of its wide bandwidth and its cost effectiveness, and also it is used in cable TV networks to provide a hybrid of optic fiber and coaxial cables, and also it is used in LANs like fast Ethernet. So the main purpose of using fiber optic cables is that they provide a faster communication and a more reliable communication compared to twisted pair cable and coaxial cable, and you can achieve communication across continents or longer distances. Finally, we need to see the advantages and disadvantages of using fiber optic cables. First one is advantages. It has got a higher bandwidth support compared to twisted pair cable and coaxial cable. And the next one is less signal attenuation. That is, a signal which is running through a fiber optic cable can travel up to 50 kilometers without requiring any repeaters. But in the case of coaxial or twisted pair cable, you may require a repeater at every 5 kilometers. Next one is immunity to electromagnetic interference. That is, electromagnetic noises cannot affect fiber optic cables. Next one is resistance to corrosive materials. That is, glass is more resistant to corrosive materials than copper. Next one is lightweight. That is, fiber optic cables are much lighter than copper cables. And the last one is greater immunity to tapping. That is, fiber optic cables are more immune to tapping than copper cables. That is, copper cables create antenna effects that can be easily tapped. So these are the advantages of fiber optic cables compared to copper cables, that is the twisted pair and coaxial cables. But what about the disadvantages? Disadvantages are that the first and the most important one is the installation and maintenance work. That is, fiber optic cable is a relatively new technology, and its installation and maintenance may require expertise which is not available everywhere yet. Next one is unidirectional light propagation. That is, propagation of light is always unidirectional. If we need bidirectional communication, we have to use two fibers. That is the another disadvantage. And the last one is the cost factor. The cable and the interface are relatively more expensive than those of other guide media, due to which again the installation cost may increase. So these are the disadvantages of fiber optic cables. So in this particular presentation, we started discussing the different topics of the second module of data communication, and the main topics that were discussed were in detail about transmission media, the different kinds of transmission media which include guided media and unguided media. And in this presentation, we discussed about guided media, that is twisted pair cable, coaxial cable and fiber optic cables. In detail, we'll be discussing about unguided media in the next presentation. Thank you.